Hey guys, I'm Alex and I'll be talking about relativity. Albert Einstein made two theories about relativity, the theory of special relativity and the theory of general relativity. I'm going to be talking about general relativity. But before we start, I'll have to explain spacetime. Spacetime is a concept that joins space and time into a single idea. In spacetime, an event may happen at one time but occur at different times for different observers. Keep this in mind while I talk. Isaac Newton's law of gravity was used for over 200 years, but there were some problems with it. His calculations couldn't explain some things, such as the precession of the perihelion of Mercury, which I will talk about later. In 1905, Albert Einstein came up with a new theory, called the theory of general relativity. It took 10 years for Einstein to include acceleration in his theory, and he completed his theory in 1915. Put simply, wherever matter exists, spacetime is bent. This curve in spacetime is known as gravity. Imagine a big ball in the middle of a trampoline. It would press into the trampoline, making it dimple. If you rolled a smaller ball around the edge of the trampoline, it would move in a spiral motion toward the big ball. This is similar to a rock in space being pulled towards a planet. Don't get confused though, a real planet would move in a circular motion around its sun, so fast that it would not get pulled in. This is called centrifugal force. In 1916, Einstein made 3 tests of general relativity, called the classical test of general relativity, to see if his theory was correct. The first test was the precession of the perihelion of Mercury. The problem was that Mercury's orbit did not behave as Newton's equations said it should. Mercury orbits the Sun in an ellipse, but Mercury's closest point to the Sun, also known as the perihelion, changes as the ellipse moves around the Sun. The rotation of an orbit is called a precession. Newton's equations calculated that Mercury's precession was slightly slower than it actually was. But general relativity predicts Mercury's precession as the right speed. The next test was gravitational lensing by the Sun. Gravitational lensing is caused when there is a massive body between us and a faraway object. It can create multiple copies of an object when there is actually just one. This is caused by the light from the distant object being bent around the massive body in between. Gravitational lensing can be used to view things that are extremely far away which we can't see normally. Einstein predicted that our Sun could be used to bend the light of distant objects because of its strong gravitational force, and he was correct. The third test was the gravitational redshift of light. Redshift happens when an object emitting light that is very far away moves away from us very fast. This shifts the color of the light up the wavelength spectrum. It is called redshift because the color shifts towards red on the wavelength spectrum. But when the object moves closer to us very fast, the color shifts towards blue on the wavelength spectrum. This is called blue shift. General relativity is used for many things in life, one of them being global positioning systems. Global Positioning System, or GPS for short, tells you where you are on the Earth. These devices are extremely accurate because the satellites use clocks that are accurate to a few billionths of a second. But because of time dilation, these clocks add on a tiny bit of time each day. It may not seem like much, but if this wasn't accounted for, it would tell you that a petrol station 1 kilometer away was actually 10 kilometers away after only one day. But many questions are still unanswered about general relativity. One of the main questions is how general relativity works with the laws of quantum physics to create a theory of quantum gravity. Thanks for listening, and I hope you learned something about general relativity.